Here, welcome back to my channel. My name is Bakri Razak Abolaji from Solis Arena Academy. So in my previous video, we take a look at uniformly accelerated motion, whereby we talk about the big four, which are known as the equation of uniform motion. Now please, if you are new to my channel, please don't forget to click on the subscribe button and also click on the like button to like my video. Then you can share with your friend. Make sure that the video gets to everyone amongst your friends that are writing next year examination. Either you are writing JAMB, you are writing WAEC, or you are writing AP Physics exam, or you are writing any external examination. You are in the right place. This video is meant for each and every one of you. Thank you. Now you see, as I said earlier on, I wanted to give you at the end of this thing some tips on how we can easily solve physics fast in examination. How do we understand the kind of question given to us? How do we analyze the question that is given to us? At the end of the video, I will surely explain that for you with question. Please stick to the end of the video so that you can get the benefit of this. Now, in my last video, we talked about uniformly accelerated motion, which I said a uniformly accelerated motion is a motion that has a constant acceleration, acceleration. And I said earlier on that you see, this kind of motion does not really exist in real life situation, but we can assume that there is a motion that is very close to it, and the motion that is close to uniformity is motion under gravity. And even though motion under gravity simply means if you have a ball that is falling under gravity, that ball can only have a constant acceleration if only we assume that the air resistance is kept constant. Now, if the air resistance is not kept constant, then the acceleration of the body will surely vary. But here, since that we are assuming uniformity, so we assume that the air resistance is kept constant. So if the air resistance is constant, acceleration due to gravity will be equal to 9.8 meters per second, which is the value of acceleration due to gravity on the Earth's surface, altogether on the surface of the Earth. Are we there? Now, although when we get to other planet like the surface of the moon, altogether, on the surface of the moon, the acceleration due to gravity is only 1/6 times that on the surface of the Earth. This is the acceleration due to gravity on the surface of the moon, which is 1/6 of that on the Earth's surface. Altogether like that. Altogether. So now let's take a look at this and how do we understand what we are given here. Now you see, I gave you in my last video that we have 4 different equations of motion of uniformly accelerated motion. I said we have V equals U plus AT, which is my equation 1. I have S equals U plus V all over 2 multiplied by time, and then I have S equals UT plus half AT squared, and I also have V squared is equals to U squared plus 2AS altogether. Now, these are the 4 equations of uniformly accelerated motion, and I explain how this equation can be used. Please, if you don't really get this, you can return back to my video on uniformly acceleration, whereby I explain to them how we can use this equation, the secret behind using of this equation, one by one in a question. Altogether. Now today, if you are talking about motion under gravity, without wasting much of our time, what we want to look at here is that we are assuming that our acceleration now is equal to gravitational acceleration due to gravity, which is constant. Altogether. Now how can we substitute each of these gravity? That means when we have an equation of motion, we simply substitute the value of gravity into the equation of motion. How do we do that? Now, please note. I can have this is my major equation, whereby the equation can be written as V equals to U plus, instead of A, I'll be having GT, and also my S. Now look at this one still remain the same as S equals U plus V all over 2 multiplied by time T. Why? The reason for this is because this one does not depend on acceleration altogether, so it remains the same, whereby this one can easily be written as UT plus half GT squared, and then we have V squared equals to U squared plus 2G. Now, take note of something. Because we are dealing with motion under gravity, Don't forget that this motion under gravity is a vertical motion compared to this one in which we have what? Horizontal motion. For an horizontal motion, we assume our distance to be taken along the x-axis. So that's why we use either x or we use what? X. Altogether, we use s or x to represent our distance. But if you are referring to motion under gravity, our s, which is representing distance, here it will be representing height. I'll be having what? H. Either we make use of h or make use of y. Altogether, so y is just to denote the vertical axis, while x is to denote the what? Horizontal axis. Altogether, so anywhere we see x here, we tend to replace it with h, which is h, and then here I will be having h. Altogether, or we have y. Now, this is our equation. But there's something I want you to note in this place here. You know, we have a body can be accelerating, while a body can also be what? Decelerating. Altogether, when a body is accelerating, we know that what? The acceleration due to gravity, the acceleration of the body will be positive acceleration. While when the body is decelerating, the acceleration of the body will be equal to what? Negative acceleration. Now, if in this case, for vertical motion, I can either throw a body upward or a body can fall freely under the influence of gravity. Altogether. So it's now left for us to determine which way are we to take the positive direction and which way are we to take the negative direction. Altogether will be like that. Now from here you see, for me, in this video, we are going to be employing one single direction so that we don't get confused. I guess when the body is thrown upward motion should be taken as what? Negative direction. That means negative acceleration. So it means my A will be equal to negative of g. When you throw a body upward, we assume that the body is decelerating downward altogether because the body tends to move slowly when it is going up. I get it. But when the body is falling downward, it tends to move very, very fast. So when the body is thrown upward, or you have a question in which you said a body, or let me say a stone is thrown upward, we should understand that the acceleration of that body will be taken as negative acceleration, negative of gravity altogether. While when the body is what? Falling downward, or you throw a body downward, we assume that the acceleration is equal to what? Positive. Now this is this shows that what the body is what? Accelerating, while this one shows that the body is decelerating. Now I can write this equation. So it simply means that the equation that I wrote here is simply for acceleration of a body. This is for acceleration of the body. What about if the body is decelerating? If the body is decelerating, my A tends to be equal to minus of g. So if I substitute into the same equation, I should be having V to be equal to u minus gt, and I should be having h to be equal to, this one remains the same, don't forget, and then my h will be equal to ut, instead of plus, the g is negative, then I'll be having half gt squared. Then I should be having v squared to be equal to u squared plus u squared minus 2gh. This is deceleration of the body. While this one is for what? Acceleration. So it simply means I can easily write the general term of the equation of what? Motion under gravity as either this v equals u plus or minus gt, and then we can also have what? H equals ut plus or minus half gt squared. Then I can have my v squared equals u squared plus or minus 2gh. Simply means that what? If the body is accelerating, we tend to use positive. I think I've explained it here. When the body is falling downward, we take downward motion as what? Acceleration, which is positive. When you throw a body upward, we take it as what? Negative, which is what? The body is simply decelerating. I want to get out like that. So I can have h to be equal to ut plus or minus half gt squared. Please note something. You might be reading another textbook. I'm using my own convention here as what? Upward should be taken as negative, while downward should be taken as what? Positive. In some other textbook, together, they take the upward direction as positive, while the downward direction as what? As negative. It doesn't stop, it doesn't alter your calculation, it remains the same. If you are using the upward direction as positive, in most cases, some of them they try to use the upward direction as positive. Why? If all the whole motion is directed downward, for example, they said a body is falling from the top of a building, and you get something. Normally the body will not go up, it can only direct all its motion downward altogether. So if all the motion is directed downward altogether, the acceleration is taken as positive. But if you are throwing the body upward, they take it as well. If the motion is into two, whereby we have upward and downward, then they will assume the upward direction to be positive altogether, because it will first of all go up before it will come downward. Then they are only employing this. If you have what? Y-axis, anything upward must be having positive Y-axis, positive Y direction. While anything downward will be taken as a negative Y direction. Anything to the right is positive X, while anything to the left is what? Negative X. This is what they are trying to employ in analysis, so it doesn't change your calculation. You might see it in different textbooks like that. That's why I need to buttress on this altogether. Now let's take a look at how to use this equation. Now, how can we use this equation? We've noticed that we have these are the three major equations that we normally use often in motion under gravity. If you are given a question on this, how do we utilize this equation? How do we use them? Altogether, please, if you watch this equation, you notice that all these three equations, they have acceleration due to gravity. Altogether. But how do we use them? What are the major things that you might be asked to calculate if you are dealing with what? Motion under gravity. Example of this kind of motion, let me say, is a one-dimensional motion. Altogether. Why do I call it a one-dimensional motion? Because the motion is only along the vertical direction. Either you throw a body upward or a body is falling downward. That is one direction. Altogether. Like this also is a one-dimensional motion. The motion is always along the what? Horizontal direction. Now, what are the major things that you might be asked to find? Let me assume that we have a body like a stone that is thrown upward. Are you getting what I'm saying now? Now, when the body is thrown upward, the body will need to get, when a body will get to a certain point in which the body will tend to drop back to its what? Initial position. The point at which the body gets to drop down to its initial position, we take it as the maximum height. That means that is the maximum position that the body can get to before the body will come down. The maximum position that the body can get to before it return back to its initial position, that is the maximum height altogether. And again, another this thing that I want you to note is that the first thing is, in any question under motion under gravity, you can always expect they will always expect you to look for the maximum height. If you are not expected to find the maximum height, they might ask you to look for the time to reach that position. At what time will it take the body to move from the point of projection to the maximum height? That is the time to reach maximum height. So these are the major question that is always given under this motion under gravity. It's either you have to find the maximum height itself, or you have to find the time it will take the body to reach the maximum height. Sometimes they might give you the maximum height, and they want you to find the speed of throw. How fast? Please note something. They make use of different English when it comes to physics, and this English tends to confuse a lot of our students. Are you getting something now? Now let me try to buttress each of these words. Now take a look at this. They can use something for you like this. Alpha. Whenever they use alpha simply means you have to find the distance the body cover. I get something now. But if I said how long simply means the time taken to take the body to cover the distance. But if I said how fast simply means what is the speed of the body. With what speed is the body using to cover that distance? These are the major words. Are you getting that they normally use? Are you getting that? When it comes to physics of motion altogether, they use this word often and often, and many students fall the trap of this by not understanding what they really meant by all this. Are you getting that? So for motion under gravity, you might be asked to find the time taken to reach there. You might be asked to find the distance. Are you getting the total distance? Here we will not take it as distance. We take it as the maximum height. And you might ask to find the speed of the body. Now let's find the formulas for this. Are you getting something now? Now, note something. I gave you something in the last video. I said, if you ask to find distance, alpha, altogether, we need to know what equation of motion am I to use. Are you getting? Come back to this point here now. if you watch this equation of motion, to know if you are looking for distance, which equation will I use? If I'm looking for time, which equation will I use? If I'm looking for what speed, which equation will I use? All together will be like that. I'll be giving you this one by one. You know, I said each of the equation of motion has 5 things. They have what? Initial velocity, the final velocity, acceleration due to gravity, they have distance altogether, and they have time. Now, these are the 5 quantities that is found there. But one of these quantities will surely be missing, and you will not be asked to find it. Are you getting the question? If you check the question, and one of these quantities is missing, and you are not asked to find it, it simply means you need to find the equation of motion that does not have anything to do with that quantity. Let's take a look at this. Look at equation 1. I have VUGT. Something is missing here. Distance, alpha. Are you getting it? It's missing in that case. It simply means in this equation, distance is missing. Altogether, if there are to use any question that will be given to you that will require you to use this equation, that question will not have distance in it, and you will not be asked to find the distance. Altogether, then the only thing that the question will have is VUGT. Altogether, I will tell you how to use this also. Now, take a look at this. This one here, it has something missing, which is V. Why this one has something missing, which is what? T. Simply means if you are given a question and there is no time in that question, and you are not asked to find the time altogether, then this equation will be applicable to solve. I get something now. Now, if I'm given a question in which there is no final velocity, and we are not asked to find it, then this equation will be applicable to solve it. Are you getting one thing? You see, physics is very, very simple, but it requires thinking. Altogether, now let's go about this. Now, I want to take a look at how we can get each of these questions that are often given to us. How do we get the equation to use for that? That's what I want to do now. Now, come back to this point here. Let me try to rub out this sheet here. Now, I think I have something of this kind. Coming back to here, you know, if you have to find alpha simply means the distance. You know, I said, if I'm asked to find the distance, I can get distance from different points here. This one is right out because it does not have anything to do with distance. But this one has distance, which is the height. This one also has what? Distance, which is what? Height. But which one am I to use among these 2 equations? That's what you need to know. That's what you need to what? Understand. To know the one that you're going to use among these 2 equations to find the distance, please note something. The distance that they'll be referring to here is what? Maximum height. What is the maximum height of the body? And note something that when you throw your body upward, when the body gets to the maximum height, the body tends to stay at rest at the maximum height. Are you getting it? It will be at rest. It simply means when you are throwing the body, you throw it with an initial velocity of u. Are you getting what I'm saying now? Now, when the body is thrown with an initial velocity of u, it tends to get to the maximum height and balance. Simply means to come back to rest at the maximum height before the body will start to drop downward again. And don't forget that when the body is at rest, it simply shows that the velocity of that body must be equal to 0. Now, what velocity will the body have here? It's going to have a final velocity because the body has been projected with an initial velocity of u. When it got here, it will have what? Final velocity. But since the body will get here and balance itself before starting dropping downward again, then the final velocity at this maximum height should be equal to 0. That is the basic condition for a body to be at the maximum height. At the maximum height, the final velocity of the body must be equal to 0. Are we together? Now, from here, I can easily find something from the equation. You know, I think I've been given 2 things here. I know about what u is been given to me is constant. Then my v, I know about my v, but I'm asked to find out what h. Then I need to look for equation that relates u, v, and h together. There is nothing like time here. I don't need time here. So if you watch here, this thing does not have anything to do with time. And don't forget, my g is a constant for this motion under gravity. So I've been given 4 things: v, h, g, and what? U. I'm asked to find h altogether. So the equation does not have anything to do with t. I need to eliminate t off, and this is the equation that eliminates it. Altogether, I'll be having v squared to be equals to u squared. Now, which one am I going to use? Am I to use positive or negative? Depends. I said earlier on that what in this video I'm going to be employing upward motion to be taken as negative, while downward motion to be taken as what? Positive. Now, since the body is being thrown upward, altogether, we assume that the gravity is negative. So from here, I'll be using minus 2g and what? H, 2gh. Altogether, now from here, what is my v? You know, I said at the maximum height of v is equals to 0, while the body is projected with an initial velocity. Now, v squared, I'll be having what? 0 to be equals to u squared minus 2gh. All together, then I'll be having, bringing this here, I'll have 2gh to be equals to u squared. Then my h will be equals to u squared all over 2g. This is the maximum height that the body will get to. This is the maximum height. So if you have to find the maximum height will only depend on the initial velocity of throw and the gravity. Again, because the body will be moving under gravity. I get what I'm saying now? So this is the maximum height that you can ask to find. The second thing that you can ask to find is the time taken to reach the maximum height. Time taken to reach that height here. How do we get the time taken? You know, now they are asking about the time taken. I'm not concerned about the what height here. Altogether, we only need at what time will it take the body to reach that maximum height. Now, the only thing I need to know is that what now we are not referring to time. We are referring to time. How do we do about this? So to get this, I have added my four quantity v, t, u, and g. I don't need h. So I'm going to write an equation that does not have anything to do with h. Let me remove this h. Altogether, this one does not have anything to do with h. Then I'll be using this as what? V equals u. Don't forget that I'm throwing the body upward, minus gt. Altogether, then I'll be having v equals to u minus gt. Then v will be equals, my v is 0. 0, u minus gt. Then my gt will be equals to u. Then my t will be equals to u all over g. This is it. Now, another thing that you might ask to find in this kind of question that is here is that they want you to find the total time of flight. Altogether, you know, here is just the time to take the body to move from here to this height here. What about the time to take the body to drop down? Please note something. The time taken for the body to move up is always the same thing as the time taken to take the body to come down to the initial position. Are you getting something now? So we can easily say the total time here, we can take it as total time spent in air. They can give a question like they say, find the total time spent by the body in air. Total time spent in air. What they are referring to here is simply the time of flight. The time of flight. So you can use the English like this. What is the total time spent by the body in air? What they are asking is calculate the time of flight. And don't forget I said something about the time taken for the body to move to the maximum height is the same as the time taken to take the body to drop down from the maximum height. Altogether. So if this time t is this and this one is time t, and we said the total time is the total time, that means the time to take the body to go up plus the time to take the body to come down, we can say the time of flight t will be equals to t plus t. Time you take the body to go up and time you take the body to come down, then I'll be having this as what? 2t. That is my time of flight. T is equals to 2t. Altogether, so that means the time of flight will be equals to twice the time to take the body to get to the maximum height. Altogether with this, hope you understand this. They can't give you any question that is related to, they can't give you any question that is not easy to solve. We can easily solve any of these questions either they ask you to find this time taking, or they ask you to find what? Maximum height. Maximum height. When we are dealing with motion under gravity, you might be asked to find the maximum height, you might be asked to find the time taking. Now note something. You know I said earlier on that sometimes the question might change. What about if they said, I said sometimes the question might be the body is directed downward like this. Downward motion. Now in this case here, note something. I said when your body is coming downward, they might just say, okay, calculate the time taken for a body like a fruit. He said a fruit is falling from what? Top of a tree. Now, let me say this is the top of the tree. Let me say we have a tree like this. Are you getting something now? Now, a fruit is now falling downward from the top of the tree like this. Initially when fruit is on top of the tree, the fruit is at rest. Automatically, it has not dropped. Initial velocity of the tree is equals to 0. He said if the body is dropping down, we'll take it as positive g. Are you getting? Then my equation of motion that I can employ here, I can easily say V is equals to either U plus GT because the body is dropping downward. Or I said H is equals to what? UT plus half GT squared. And we said, or I said V squared equals U squared plus 2GH. When a body is dropping, again, we can give a kind of motion like that. Okay, body is dropping. In this case, you are not throwing the body, but it's dropping downward by itself. Then you employ the positive gravity aspect of it. All together. Positive gravity aspect of it. That's not what you employ. Now, so from here, I'll be using any of these equation. Now let's take an example on how to solve this. Now let's take a look at this question, this lovely question that is here. Now let's take it from the scratch. I'll be explaining some basic thing here that you need to understand. Okay, let me use this place here so that we don't get confused. It said a boy throws a stone vertically upward into the air with a velocity of 6 meters per second. So use the convention I've given to you that you assume your upward direction as negative for the acceleration. So here my acceleration will be equals to minus g, which is same as what? Minus 10 meters per second. That is my acceleration because the body is thrown upward. Now I said with a velocity, it throws me to what? U is equals to 6 meters per second. And then the stone reaches the maximum height and falls into the sea, which is 12 meters below. I need you to understand something. It falls into the sea, which is 12 meters below the point of release. All together. Now, note something. Let me draw something for you. If this is the normal height in which the body is being thrown, all together. Now the body is thrown upward like this. Then after the body is dropping, it falls below. 12 meters below the point of what? The point of throw. This is the point of throw. The distance from here to here is 12 meters. Now, the point of throw is taken as the what? Reference point as 0. Distance 0. Anything downward like this must be what? Negative. Simply means this point here downward like this is negative 12 meters. The height is negative of what? 12 meters because it is below the point of throw. Anything above the point of throw should be positive. Anything below the point of throw should be what? Negative. So from here, my height will be equals to minus 12 meters because it's below the point of throw. Now, then I said, okay, which is 12 meters below the point of release. Calculate the velocity at which the stone hits the water. What is the final velocity that will take the stone to hit this water? Now, what will be my final velocity of the stone? Final velocity, we don't know. Now, which equation are we to use? We need to employ equation of motion that only have initial velocity, initial acceleration, height, and what? V, final velocity. Then what is the equation that we're going to be using here? V squared equals to what? U squared. Please don't forget my A is negative. That will be minus 2GH. Now, let's try to solve this out. From here, I'll be having my V squared, that's what we're looking for. My U squared is 6 squared minus 2 times G is 10 times my height is minus 12, and I'll be having 36 minus, minus is plus. 2 times 10 times 12 should give rise to 240, and then this plus will give rise to 276. That's my V squared. My V will equal to square root of 276, which should give rise to 16.6 meters per second. This is the velocity of the body. Can you say it's very, very simple to solve? Altogether, just understand the convention, then you solve. Now let's take a look at the second question that is there. The second question that is there is said, if an object is thrown straight upward with an initial speed of 8 meters, they throw the object with an initial speed of 8 meters per second, and takes 3 seconds to strike the ground. The time to take the body to strike the ground is what? 3 seconds. Are you getting what I'm? Now, then I said, from what height was the object thrown initially? From what height? What is the height of throw of the object initially? This is very, very simple. Also, what is the last quantity that is missing? The last quantity here is G because we are referring to what? Throw, which is G is always the constant throughout that kind of motion. So my G is what? Now, here, they said from what height was an object is thrown straight upward. Since that the object is thrown upward, then my acceleration should be equal to minus G, which is equal to minus 10 meters per second. Now, the now asks us to find the height of throw. How do we get the height of throw? We already know that my h is what 8 and this one is what 3. Now how do we calculate this? We can easily calculate like this. Since my height equals, use the equation that relates only u, t, h and a, because v is missing here. And the only equation that has v to be missing is h is equals to ut. Then this will be minus half g t squared because you throw it upward. All together. So minus half gt squared. Now let's continue. Let's start with something great here. Now from here, I can easily have my u to be equals to 8 times my t is 3. And then minus half, I get something now, times my g. Now what my g? My g is equals to 10 times my t is 3 squared. All together. And then I think I can have something here. So we can cancel this to give rise to 5. 5 times 9. I'll be having 8 times 3 is 24. 24 minus 5 times, this is 9. 5 times 9 will give rise to 45. Now 24 minus 45. 24 minus 45. That should give rise to 12. 21, sorry. I'll be having what? Minus 21 meter. Now, one thing is that what? The body is being thrown at an height of 21 meter because don't forget that the body will fall below what? 21 meter. I get it. So let me say the height, this is where the body is found. I get what I'm saying now. So it is thrown from here. The height below the ceiling, below the what, level of throw, the height that is below the level of throw is equals to what? 21 meter. Don't forget I said something earlier on. I said something that if this is the level of throw, I get what I'm saying now. Anything below the level of throw will be taken as negative. Anything above the level of throw will be taken as what? Positive. So the reason why my answer here is negative is because the height is below the level of throw. That's why we're having what's negative. So at what height is the body being thrown? The body is thrown at an height of 21 meter. 21 meter altogether. So it is thrown at an height of what? 21 meter below the level of what? Projection. So this is the height. So forget about the negative. Negative does not have anything to do there. It's just only to explain to us that the body is thrown, as in the height at which the body is thrown is below the level of throw. Thank you for watching this video. Please don't forget to click on the subscribe button to subscribe to my channel, and also click on the like button to like my videos. Share the video with your friends and family, and also make it go around for those so that you can help a lot of people that are writing exam next year, because this year has run down completely. We pray what we should be able to complete this year, and also we should see again by next year to write the same examination altogether. For those of you that are preparing for next year examination, either YF, JAMB, or any forms of exam, you are in the right place. Search Arena is meant for you. Thank you for watching. Please give us a thumb up. Thank you.